Comprehensive explanation of Kubernetes NodePort service request flow. Overview. A NodePort service in Kubernetes exposes an application to the external world by mapping a specific port on each Kubernetes node to the service. It enables external clients to send requests to the cluster and have them routed to the appropriate backend pods. This explanation outlines the end-to-end request flow through a NodePort service, highlighting each component's role in handling traffic and ensuring efficient communication. 1. External client sends request. The external client begins by sending a request to a Kubernetes node's IP address and the node port assigned to the service. The node port is an externally accessible port from the range 3000 to 32767 that Kubernetes assigns when creating a node port service. 2. Node receives the request. The Kubernetes node receives the request at the specified node port and identifies the corresponding node port service within the cluster. This mapping between the external port and the internal service allows seamless communication between external clients and backend pods. Forwarding request to node port service. The node forwards the request to the node port service, which serves as a bridge between external traffic and Kubernetes services. This ensures that incoming requests are routed appropriately for further processing. Hat 4. Node port service forwards request to Kube Proxy. The node port service sends the request to Kube Proxy, a critical component responsible for identifying and managing the pods associated with the service. Kube Proxy acts as a traffic controller, determining which backend pod should handle the request. 5. Kube Proxy identifies available pods. Kube Proxy consults endpoint objects, which contain the list of pods linked to the service. It ensures only healthy and ready pods are eligible to handle traffic. 6. Pod selection and load balancing. Kube Proxy selects a backend pod based on its configured load balancing algorithm, e.g. round robin or random. If one pod is selected, it receives the request and processes it. The load balancing mechanism ensures even distribution of traffic across all healthy pods. 7. Response routing via NodePort. The selected pod processes the request and sends a response back to Kube Proxy. The response flows through the NodePort service and the node, ultimately reaching the external client. This step ensures that the client receives the processed data seamlessly, completing the request-response cycle. 8. Workflow completion. The entire flow concludes with the client receiving the response from the backend pod. The NodePort service abstracts the complexity of pod management and ensures efficient communication with external systems. Key features of NodePort service. Comprehensive explanation